Okay, so in this video, we're going to look at what it means to prove or establish identities or trig identities. Just kind of give us an idea of what we already know, which is actually quite a bit. All of these are identities, and we can complete the statement by putting something that's true, to make that statement true, the left and the right. So sine squared theta plus cosine squared theta. So that's a Pythagorean identity. It's something that we just had a test on. We know that's equal to 1. Sine of negative theta is equivalent to negative sine of theta. That's the even odd property. And I know there's more Pythagorean identities, and I know there's more even odd properties. Reciprocal property, the reciprocal of sine of theta is cosecant of theta. Here's another even odd property. Cosine of negative theta is the same thing as cosine of positive theta. 1 plus what equals cosecant squared. Again, that's one of our Pythagorean identities, is 1 plus cotangent squared of theta equals cosecant squared theta. If you have cosine over sine, that's the x component over the y component. That's the same thing as cotangent of theta. And then tangent of negative theta, it's an odd property, so it's negative tangent of theta. So all of those are pretty straightforward in terms of known identities, things that we already know. But we start kind of combining things through different operations, and then it may not be so obvious. And that's sort of the whole point of example 8, in this moving forward, that we're going to look at an equation, and we've got to establish or prove that it is true. And you want to manipulate and change and reduce and use trig facts to make this an equal statement. Now, here's the thing. You want to treat this equal sign as something you cannot cross. So I want to pick one side, and usually it's the more complicated side, like I'd pick this side, and I want to start manipulating that to create the right side. Do not change the right side. Don't multiply across the right side. Just manipulate the left side. So one thing I might do, and it is a bit tedious. There's a lot of writing. A lot of times it's helpful to write tangents and cotangents and secants and cosecants in terms of sines and cosines. So I might write tangent as sine of theta over cosine theta, and then I'd write cotangent as cosine of theta over sine of theta. So I'm not changing anything. I've just, expressed tangent as an equivalency and cotangent as an equivalency. And I'm actually now going to add these up on a common denominator. So cosine theta times, to get a common denominator, what I'm going to need to do is basically multiply each of them by their opposite value. So, for example, this first one, I'm going to multiply by sine theta over sine theta. It's a fancy one. And then this one, I'm going to multiply by cosine theta over cosine theta. So I'm just trying to find a common denominator. And I would equate it, it's very similar to if you wanted to add the fraction 2/7 plus 3/5. You would take the 5 and put it up there. So 2 times 5 is 10. 7 times 3 is 21. And then, it would be over 35, that common denominator. So the same thing is happening here. So when I do that, I still have this cosine of theta. That's fun. I thought I'd kept red. Now this becomes sine squared theta. And I can't really simplify this. It's just like sine theta, cosine theta in the bottom. And it's a product, so the order doesn't matter. It's commutative. And this is cosine squared theta over sine theta, cosine theta. Now you really only want to do one step at a time. And then I can add those up. And don't do too much at once, because you really are trying to show that, the left side is equal to the right. So it should be very clear, what you're doing step to step to step to simplify. Notice we haven't really changed this. It still equals, still equals, still equals. But now this is great, right? Because I know exactly what sine squared plus cosine squared, sine squared plus cosine squared is. And it's 1, right? So that up there can be replaced with a 1. So again, don't do too much though. But we can call that cosine of theta times 1 divided by sine of theta cosine theta. And then I'm seeing, right, I'm seeing that cosine theta will cross out this cosine theta. So now all I have is 1 over sine theta. And again, don't do too much. And what is 1 over sine theta? Oh yeah, it's cosecant of theta. And as soon as you get the left to equal the right, then I like to just rewrite it to verify, yes, this identity is true. And notice, we didn't multiply over to the right. We didn't multiply both sides or add something to both sides. We just manipulated the left side and we made it equal to the right. And that's how I want you. That's why I modeled it that way. Because that's how I want you to do that. Now, takeaway, from that, finding common denominators. Really, that was the key right there, is finding that common denominator, because then that led us into a Pythagorean identity. Will that always be what you do? Not necessarily. And the thing about that makes this section tough is that sometimes, you're like, you don't know what to do. And so you just kind of try some things until eventually, you get used to and recognize different skills and strategies. Okay, so let's look here and let's see what's happening. And so, I'm trying to show that the left is equal to the right. And the left looks a little bit more complicated than the right. What I might do is actually maybe just maybe multiply this out, because in the back of my head, I know there's a Pythagorean identity. I know there's like a 1 plus tangent squared theta is equaling secant squared theta. And so if I could somehow think about that, I see tangents, I see secants, maybe that's going to come up in my problem. I don't know. So let's find out. So I'm going to, again, you just use the left side. And let's distribute this out. So secant times secant. So secant times secant would be secant squared theta. And then we get plus secant tangent theta. But then we get its opposite right there, which is really nice. Minus secant tangent theta. So I know that those are going to cancel. Now, if you write it like this, and then minus secant theta tangent theta, that's fine. And then minus tangent squared, like that. And so then all that is divided by secant of theta. And we're not changing anything. Now, perhaps you knew that the middles were going to cancel. So perhaps you already knew that that was going to cancel with that. So your first step may have been secant squared theta minus tangent squared theta all over secant of theta, which is fine. And now I'm thinking about this Pythagorean identity. What does that equal? What does that equal? Well, if this is the identity, then if I just would have moved that over, so 1 would have been secant squared theta minus tangent squared theta. So if you're just substituting a Pythagorean identity, that really you don't have to show any, that is your work, right? So that numerator is 1. So I know that through a Pythagorean identity that's true. And if you wanted to put off to the margin just to remind yourself, oh yeah, that's a Pythagorean identity, that's fine. That kind of shows what you're thinking, and that's great. But again, thinking about how streamlined this is, what I'm doing is just changing the left side, right? So this should be very clear that, like this side is going to be changed and manipulated to equal the right. Now, we're one step away. Explicitly tell me what is 1 over secant. Oh yeah, that's cosine. And what are we trying to equal? Oh yeah, cosine. So, again, thinking about what are we doing? We're using known identities. We're using things that we can manipulate trig-wise to try to get one side to equal the other. Okay, so I think, let's see, maybe if we look at, let's go ahead. Let's go ahead. I'm going to go ahead and stop this video, and then I'll put another video together, and we'll look at the next 2 examples. And certainly, if you want to give those a try before you see the video, I think that's kind of my intent here, so that that's how you're going to get good at this. Is trying to manipulate, try something, and see if things cancel, and simplify, but do not cross over the equal sign. Don't multiply, don't add, don't change anything on one side. Just pick one to simplify.